Hello, how the tech are you? I'm going to make an executive decision and assume we're all doing tech and great.
Hooray.
Yes.
Yay.
that bit would have got real tired real fast.
Yeah. It's probably still getting tired, but at least a little bit different. This is our weekly tech show on Echoplex Media. We talk about tech stuff, sometimes news, sometimes whatever we feel like talking about. I think this week we're doing a lot of whatever we feel like talking about, but it should be fun. So what am I talking about? I'm historian Matt, and I am talking about China warns of a rogue state hackers. So a certain rogue state is sending out hackers. We'll have to hear about that. And then in my second section, we're doing part 2 of Learn to Lisp, and I'm calling it Electric Function Boogaloo. So, guy with the pink mic.
I am HK Perrin, and I am a software developer, so I cover mostly software development news. And this week, I've got 3 stories. First one is GitLab 15 was released. Second one is Alpine Linux 3.16 was released. And the third one is TypeScript 4.7. I have an update to that one. The stable version was released. A few weeks ago, the beta came out. The full stable TypeScript 4.7 just came out. So I'll be talking about that this week. Over to Dave.
This week, I'm Dave. I'm a content creator. I use open source to create content. You might see some of that content, and you could check out some of the other content by searching for Echoplex Media, but you don't have to do it. This week, I'm going to talk about something that everybody was really mad about on all the mailing lists that I am on for Linux. And over to Matt.
All right. I will get started with my first topic. So China warns of rogue state hackers. What state is that? The United States. Go figure. So obviously this is, the United States has been hacking other countries for a long time. China is notorious for their hackers as well. And basically what's happening, if you've been hearing about this recently, is China's foreign ministry and cybersecurity firms have been calling out the U.S. a little bit more recently. It's probably sort of a clapback since the U.S. has been calling out China's hackers over the years. And, but really, are you surprised that the United States is hacking other countries? Either of you?
No.
Surprised?
No,
not at all.
Like every country hacks other countries.
Yeah.
It sucks, but it happens.
It's just espionage. Yeah. It's like, why are you spying on me? And it's like, well, how did you find out that we were spying on you? Well, we were spying on you.
Exactly. Yeah. So the weird thing about this, what's been going around recently, is the allegations include like pretty old technical details. A lot of the exploits that they brought up were publicly known exploits. So like some of the stuff they're complaining about is like probably years old now, right? And nobody's entirely sure why they're doing it, but it sounds like it's probably because they don't want to actually reveal any exploits that they're using, So there's no actual like technical info in their releases.
Well, not for nothing. A lot of times, if you reveal what you found out that someone else is doing, somebody can reverse engineer that to figure out what you did to find out what they were doing. So,
right. Yeah, that too.
Going back a few years makes it like irrelevant, like what they were doing or how they found out about it because it happened 5 years ago or whatever. So this is all the Spider-Man meme again.
Yeah. Yeah, so that's all I have for that one. There's not really a whole lot, and I didn't see like much other news that I wanted to cover anyways, and I thought this one was funny because it was, China calling, they didn't really call the US a rogue state, but it was, they kind of did. It was pretty funny. So moving on, unless anybody has any final comments, I want to move on to the next part. Doesn't sound like it. Okay. So part 2 of my Learn to Lisp, and basically trying to teach Hunter like a real programming language. We're going to be covering functions. I'm calling this one Electric Function Boogaloo, because you always got to call part 2 Electric Boogaloo something, right? I don't remember where that started, but that's a thing. But before we like really get into it, I want to talk a little bit. I'm doing a switch to Clojure. So before I was using Common Lisp, and I've been having a little trouble finding all the info I need for Common Lisp and going over these things. I'm pretty sure Common Lisp covers and supports a lot of these things, but I am much more familiar with Clojure. I've been working with it for a long time. And Clojure is a Lisp variant that runs on the JVM, so dialect of Lisp. It does a lot of stuff like Lisp. There are some small differences. Another nice thing about Clojure is there's Clojure Script, which is another version of Clojure, but that one actually runs, it targets JavaScript, so that like it gets compiled to JavaScript and you can run it in a browser. And there's some niceties of having both of those. Oftentimes people, when doing a web app, they'll use both of them at the same time. I'm looking into using Clojure Script for another little project that I'm working on that hopefully we'll hear about more later. Any questions?
I have an interesting tidbit. You mentioned JavaScript, and Brendan Eich, the guy who invented JavaScript, he was actually originally hired on to implement Scheme in the browser.
Wow.
Which is a variant of Lisp. So originally browsers were very close to running Lisp instead of JavaScript.
Yeah.
And the management essentially decided that instead of implementing Scheme, they would task Brendan with coming up with his own language.
Okay. Yeah, that seems kind of strange. And they came up with JavaScript, which I feel like is kind of a weird language, but the language itself is okay. I think it's a lot of the other stuff that comes with it. Anyways, first thing I want to do is cover some stuff that I missed on the previous part related to Lisp, and talk a little bit about, well, at least one difference Clojure has from Lisp, because that's going to come up in this section. So the first thing is I forgot to actually mention a list literal. So if you want to make a list in Lisp and use it as a list, right, you have to do something. And in this case, you can make it literal by putting like a single quote in front of it. And that just says, don't actually you make it, you're always making a list in Lisp. But if you don't put the single quote in front of it, it tries to evaluate it as a function. In this case, I have the list, it's tick, and then, or quote, and then open parentheses, 1, 2, 3, and close parentheses. If I didn't have the single quote in front of it, it would try to use the number 1 as a function and then freak out and fail. So that's one way you can do a literal list. In this case, if you put the single quote, it just makes a list. But I think that they have another way to use an actual list function. But I think they did that because it's really easy to miss that single quote. So instead, there's an actual function called list, L-I-S-T, that then you can just pass the items of the list as parameters. So in this case, I have 1, 2, 3. So people who are watching the video can see what I have on the screen, but I just have basically a function call in Lisp with the function list and the parameters 1, 2, and 3. And that will return, I didn't put the return here, but that will return a list that includes the values 1, 2, and 3. And then you can do list processing in it, which I'll talk a little bit about, I think, in this one. But I think part 3, I'm going to do like a much deeper dive into doing all the list processing and all the fun stuff with lists that actually make Lisp a nice language to use. But in Clojure, we also have another thing you can use, which is called a vector. And this is kind of like something that makes Clojure look a lot different from other Lisps in a lot of ways. So instead of making a list using parentheses, a vector is very similar to Lisp, but you create it with square brackets. So you have like in this case, I have the open square bracket 1, 2, and 3, and then the closed square bracket. And that makes a vector. What's the difference between a list and a vector? I don't want to go into all the low level details, but you can kind of think of a list as, well, basically a linked list. And if I went into deeper, it's actually, in many cases, a singly linked list, and the reasons for that. But a vector is more like an array. It is immutable. I haven't gone over that sort of stuff yet, but both lists and vectors are immutable. But internally they work, the vector works kind of like an array, which basically gives you access that you don't have at a list. Any questions?
So like in a vector, each element has a certain amount of memory.
Well, in a vector, I don't know all the details. Usually it's like Clojure runs on Java. So this is probably an array of object pointers. Okay. So it wouldn't be actual, like, it would be the pointers, not the actual objects in this array.
Okay. So
it's a little bit weird because
put things that are different sizes into the vector.
Yeah.
Okay.
And you can put anything you can put anything you want, just like a list. You can put that into a vector. This becomes useful. There's certain things you can do that are interesting with mixing objects and vectors and stuff. That I may go over later. I don't know if it'll end up in the list part or what. But I mean, one of the big things with a vector is you can actually index it pretty fast. So you can go to like the first item, the second or third, or the 100th item pretty quickly. But with a list, you actually have to step through everything to get to the item. That's one of the big ones. Anyways, but I wanted to make sure I mentioned vector before I move on to actually defining a function. So yeah, in Clojure, what we have up here is how we define a function. It's very similar to common Lisp. I'll talk about that in just a second. But for those who are listening in, basically what we have is open parentheses, defn, DEFN, which stands for define function. And then after that, this function is called add. So we have the symbol add, ADD, followed by a vector containing x, y. X and y are symbols, or the parameters to the function. And then after that, I mean, there's some other stuff you can add to the beginning, but this is like the most simple type function, right? After the vector that holds the parameters, you have the actual body of the function. In this case, there's only one form, basically, and it's a function called to the plus function. And that plus function, I'm passing an x and y to basically add x and y together. And the result of that function call is, of course, x and y added together, and that's returned as the result of calling this function add. And then, of course, we have the ending close parentheses. The big difference between this function, which is a Clojure function, and a common Lisp function, is you don't have the vector, but instead that would just be another list. And I think otherwise it pretty much looks exactly the same. I think they even use defn. Any questions on this? I'm kind of like, I'm using this add function for fun, but the plus function really works exactly the same way. But I'm pretending for now that the plus function only takes 2 arguments. Good. So let's add a little bit to this. So this one I don't have centered nicely because I'm starting to add more code, but say you want to have multiple invoke methods. Basically, you have different number of parameters you want to add to this add function because, well, this, I really simplified it. Maybe you just want to add one number to nothing, which doesn't make any sense. But for certain cases, you may, it's like it can act as an identity function may be useful in the future where you don't know how many values you need. You kind of need to support the one parameter version, or you can do two parameters. And basically how you do that is you encase the vector that you want, which is the number of parameters, and the body for that particular set of parameters in parentheses. Just a second. Quick cough. So in this case, I have a 1 and 2 parameter versions. The first one is after the name add for the function. We have the open parentheses and then the open square bracket for the vector, x close square bracket, and then the only thing we're going to do is return x and then end parentheses, and that is the first version, the single parameter version. And then the second one, which is 2 parameters, do open parentheses, open vector, or open square bracket, x and y and close square bracket. So x and y are the parameters. And then the body of that version of the function is the one we had before, which is open parentheses plus x and y close parentheses. Then we have another parentheses to close that version of the method, and then we have another parentheses to close the overall function.
So this is similar to polymorphism.
Yes. So this is basically, you have different number of parameters you can call the same function.
Yeah. So in object-oriented languages, polymorphism just means like you have different function signatures for different things that a function could take. So you might have something to add floating point numbers and something to add integers, and you could have the same function just like you have here, but it accepts different arguments.
Right. In this case, it's different number of arguments, which you can also do with, I think you can do that with polymorphism.
Yep.
Yeah. So the next one, we're going to add a little bit more to our add function. And the first 2 versions of this function are the same, but I've added in the third version and more. So it's ampersand more added to the parameter vector. So the whole vector is x, y, ampersand, and I have a space more. I think you can actually get rid of the space. I don't remember exactly. I did it with the space and it definitely worked when I ran it. And that's a whole vector. And I'm sure you can probably guess what and more does.
Does it give you a vector of the rest of the arguments?
Yeah, actually, I think it's specifically a list, but it'll collect all the rest of the arguments, which means you can just add as many arguments as you want to
so it's
version.
Similar to what I would call a rest prop.
Yeah. Yeah. But to use this, we have to do something a little bit different. I use the apply function, which is a function that takes a function as the first parameter, and then it'll take the rest of the parameters will be applied as parameters to the function that you're passing in, except for the last one, which if the last parameter is a list, it actually what's called destructures it basically, and uses each item in the list as a parameter to the function that was given. So in this case, the apply function, I'm giving the add function, which is the function we're already in. So we're actually calling ourselves. And the first parameter, I'm just adding the first x and y together and making a new, using that value and passing it to add. And then I have more just sitting there because more is already a list. So each item in the more list will be applied as parameters to the add function as well, the following parameters.
So in the next invocation of this function, the sum of x and y would be assigned to the x,
yes,
the x argument, and then whatever the first element of more is would be assigned to the y argument.
Correct. Exactly.
Okay.
Yeah. So that's great. And I'm introducing a little recursion here, right? So the function is calling itself. But So I want to go to the last version, and I've added a little don't do this. I'm using, it's actually a special form. It's not a function, but it looks exactly like a function. And it does some special stuff. So it's called recur. And I'm doing this function does pretty much exactly the same as the previous function, but it adds a lot of extra stuff. I've added an if statement, and the reason I added that if statement is because the call to recur like screws up if I just throw in more, and it has to do with the number of parameters not matching. So the first thing I do in this if statement is just check to see if more is empty. If it's empty, then I'm just working with X and Y. So it should be exactly the same as the other version of the function that just adds X and Y. And I could call that, but I decided to just straight call plus and just have it return X and Y. So the other part of this if statement, you notice there isn't a then kind of thing around it. It's just there's two different basically function calls in the if statement. The first part is, or there's actually three, because you have the conditional, and then you have what you do if it was the conditional was true, and then the second one if it was false. In this case, I call recur if it's false, and what it's doing is it's adding the X and Y together, and then calling the first function on more, which returns the first item in more, and the next one is calling rest on more, which returns all the items as a list of more, excluding the first item. First and rest. The combination of those two functions are used very often because you're basically like using the list as a queue or a stack, depending on how you're using it. And first is basically popping off the first item, and rest is like getting the rest of the stack, or the rest of the list as a stack.
It's like shift in JavaScript.
Yeah, probably.
Except in JavaScript, shift mutates the list, the array.
Yeah. So the problem
you're never mutating the array, right? You're always just returning other copies of it.
Yeah, so technically this list more is not getting changed. It's immutable. But first is just pulling out the first item, and that doesn't change more at all. Rest doesn't actually change more. Technically, it like makes another version, right? Except that more is like a singly linked list, so, and that's immutable, right? So all you do is you basically point to the second item in the list, and that's exactly the same. There's like, you don't have to change anything, right? You're not actually making any copy except where you're starting the list from. So that's
really
how
neat.
that kind of works.
Yeah, the if function looks a lot like ternary operators.
Yes. There's some tricks to it. Like you don't actually have to have the second version. So it would just be a, straight if statement without a then clause to it.
Okay.
You can't do, there's a different function if you want to do basically if else kind of thing to it, but I don't want to cover in this. But if you're wondering why first of all, recur, if you haven't figured out already, basically calls add, the add function from within itself. And the reason why I'm doing it here is something that is kind of unique to functional programming. I don't know if you've ever seen something like this. Can you guess what's happening here?
In the recur call?
Yeah.
Not really.
Yeah. So it's calling add again, and I could have just like the way it's written, I could have just added add there as a function, and that would make it recursive. But what happens if you call the same function within the function, right? It's recursive, that's fine, that's something that's supported. But one of the things that has to happen is it adds to your stack, right? When you recall a function, and then when that other function returns, it kind of unwinds the stack as it goes up. And in this case, it's the very last thing that's happening in the function call. So you're kind of like building up the stack for no particular reason. I mean, as soon as it ends, right, you finish the recursive part of it, it just returns everything, right?
Yeah.
So what recur does is it calls add, but doesn't actually add to the stack.
Interesting.
It's making like a whole new function call in place without adding the stack, because you know that what comes out of recur is just going to be returned. And that is called tail recursion. And it's a way of basically making loops in a functional language using recursion without eating up your stack.
Huh.
Yeah.
That's really neat.
Yeah. I don't know if you've used a lot of other functional languages. They're in a few other languages. It does this sort of thing. This is really cool. It looks nice. Well, it doesn't look great because I had to do a bunch of extra stuff to get it to work. And that had to do with the parameters in recur had to exactly match the last version of the add function, the way I had it set up. That's why there was a lot of extra stuff added and made it look ugly and had to add the if statement. But it does work. Generally speaking, you don't do that because you just don't have to do that. And I'll go over that in part 3. It's already up to part 3, when we'll be actually processing lists and vectors, but mostly lists. That's it.
That was really cool.
Cool.
I have no
Good.
idea what you're
I'm glad I
talking
found
about, but
something that you
HK,
didn't
I have no
know
idea
about.
what you're talking about, but HK sure seems to think it's cool, so I agree.
Hopefully some of our listeners or viewers know about it. You kind of have to have a programming background to know what I'm talking about.
Yeah. I've never actually seen Clojure. The only form of Lisp I've ever even really interacted with more than just like glancing at some code is Scheme, and that's because I wrote an extension for GIMP.
Okay.
And GIMP extensions are written in Scheme.
Okay. I didn't know that, but I'm not surprised because there's a number of programs that have some form of Lisp as their language for doing extensions.
Yeah, it seems like it would be relatively easy to create an interpreter for it.
Yeah. It is.
I mean, I'm
usually
not saying like it would be easy. I'm saying I mean it would be relatively easy compared to like creating an interpreter for say like PHP, which would be monumentally difficult. So, should I move on to my stories?
Yeah, go for it.
All right. So, recently, GitLab 15 came out. GitLab is a DevOps platform. They also do code repository hosting. They're similar to GitHub. But unlike GitHub, GitLab is actually open source, which is interesting because GitHub is where a ton of open source projects are hosted, but it itself is not open source.
Okay.
Yeah. And also, for a big notable project that I'm sure both of you have heard about, GNOME is managed on GitLab. So GNOME does all their project on GitLab. So GitLab 15 came out with one of the really cool things they added is container scanning in all tiers. So basically what that means is even if you're on the free tier and your project is, you're not paying to host your project there, you can still implement this container scanning feature, which will go through all of your project looking for containers that you use to run your code and scan those containers for vulnerabilities and tell you about those vulnerabilities. That's a really cool feature. Another neat feature they introduced is internal notes to discuss a public ticket privately in an organization. So basically, if you have an organization where someone has created a public ticket and you would like to discuss that ticket privately with, say, a customer or say inside your team, you can use these internal notes to discuss that thing privately. Something that I think would be really cool on GitHub. I don't know if GitHub actually implements that already, but I'd love to see it. My next story is Alpine Linux 3.16 came out. Alpine Linux is a super tiny Linux distro that's based on muscle libc and BusyBox. Muscle libc is an implementation of the standard C library that's quite a bit smaller than glibc, which is the standard one that most Linux distros use. So using muscle libc and BusyBox, Alpine Linux is essentially a Linux distro that is incredibly small. And a lot of people use that in things like containerized applications. Things like Docker containers will often run Alpine Linux on the inside of the container so that it's a very small package. You don't have to download an entire like Ubuntu distribution, for example.
How small is very small? Bytes.
I think all of Alpine Linux is like, I could be wrong, but I think it's like under 100 megabytes.
Wow.
So it's incredibly small.
Yeah.
Some of the updated software in this version are, it includes Go 1.18, GNOME 42, PHP 8.1, Node.js 18.2, Python 3.10, and a lot more, but I'm not going to go through all of them. And some notable things that were removed: PHP 7 and Python 2 were removed in Alpine Linux 3.16. So if you rely on those, don't upgrade.
They're removed because they've been updated, right?
Yeah.
The old versions
PHP 8.1 replaced PHP 7, and Python 3.10 replaced Python 2. For my next story, TypeScript 4.7 was officially released. This is an update from a story that I talked about a little while ago. TypeScript 4.7 beta came out a few weeks ago. This is the full release of TypeScript 4.7. And one thing that's different between the beta and this release, which might catch you if you're a TypeScript developer, is TypeScript 4.7 now requires Node 16 for ECMAScript modules instead of Node 12. So if you're using TypeScript 4.7's new ECMAScript modules, you have to be on Node 16 or higher. I think that's my understanding. I hope I'm not wrong. If I am wrong, let me know in the comments. But the big feature that everyone's excited about is support for ECMAScript modules. TypeScript can now output ECMAScript modules, and it can understand ECMAScript modules. I mean, it could before, but now it can output ECMAScript modules. So if you'll remember back a few months ago, I was talking about JavaScript getting a new update back in, I think it was like 2014 or somewhere around there, that introduced, it was called ECMAScript 6, basically JavaScript 6, that introduced a new concept called modules, which is similar to something Node.js had already been doing. And it allows you to package code a lot easier and be able to use it from another place in your, or to export it for use for with other people's code, or to use it in your own code somewhere else. So yeah, TypeScript 4.7, big excite about that. And that's all for me this week. So let's head over to Dave.
Yeah, mine's going to be pretty quick this week, mostly because it's early days for the thing that I'm talking about, and we don't really know what it's going to be. But let me tell you, on all the mailing lists and on Slashdot and everywhere, everybody got an opinion, that's for sure. So it looks like via systemd, there's going to be some way in which it mostly enterprise CPUs will allow you to unlock features that are pieces of hardware in the CPU. So people are like calling this CPU as a service in some of their more derogatory posts about it. So if I was going to steel man this or say like a thing that could be good about it, right? Instead of like complaining about you buying this CPU that then you have to pay them some more money to give you the rest of the CPU you bought. Let's say you don't have a lot of money and you want to start a data center. And so you buy, I don't know, whatever, Xeon CPUs for $200 each. And then as your business starts to make money, you can unlock more cores. Maybe virtualization is a feature you can unlock later so that you can run a bunch of VMs on the CPU. And that's the steel man of it. But the deal is that you'd be buying a piece of hardware that you can't use all of the features of because the software is going to limit you, and you would have to send Intel more money to unlock more of the features, possibly as a subscription service, which sounds terrible. It sounds quite terrible. It's early days on this. I think there's some chance they're going to walk this back because people are angry as they might be. But if things go as they're looking as it looks like they may go, you're going to see this in fall releases of Ubuntu and Fedora. Like in the Ubuntu, it'll be like the 2210 or something is likely to include this new version of systemd. And it's not going to matter for me or you or anybody who has a currently existing CPU. It's not going to like lock down if you have 8 cores. It's not going to be like, haha, you have 6 give AMD your money or whatever, right? It's going to enable this in the future. And so it just reminds me of a thing that happened in 2010 where it was like a Best Buy exclusive where you could go to Best Buy and you bought a Pentium G processor and you could buy a little unlock card for $50 and it would unlock hyperthreading on that processor. And here's an angry article from ZDNet about it that I found, because that's when this came around, right? When this hit the lists, I'm like, well, this isn't really something I super understand very well. I'm not like a systemd expert or anything like that, but I'm like, this really reminds me of this. And so up on the screen, here's a picture of the card that they were selling exclusively at Best Buy. It was a Pentium CPU upgrade card. And this story just reminded me so much of this. And everybody was so mad because like you bought this CPU, right? And it had all the hardware that you had paid for in it. And then they were like, well, actually, no, you have to buy this card to use all the stuff that's actually in this thing that you physically own. And I don't think that the Linux community, the people who use Linux in the data centers they're not going to like this. First of all, I think that they're going to crack it immediately, right? You're going to have to jailbreak your processor, which is going to be a weird thing.
Is there already a betting pool for that?
That's interesting. Yeah, if maybe we could set something like that up, because this is something I kind of want to keep an eye on, because I think this is dumb, and I'm really surprised that the systemd team like kind of went along with it. Honestly, it doesn't seem like it's in the spirit of open source software in any way, shape, or form.
Yeah,
and yeah.
I
wouldn't be surprised if someone forks systemd and removes this code.
Right. When systemd came out in the first place, everybody was forking it. Do you remember that? Everybody was hell mad about systemd when it first came out. So there could be a way in which maybe the people who the systemd team just doesn't want to rock the boat. They don't want to piss off Intel. And maybe they know as well as we do that somebody's going to crack this, right? That somebody's going to have a solution where it's going to make it so this is, like a useless feature essentially, because you patch systemd in a certain way and it just completely unlocks this processor. That will happen. It won't not happen. There's no it could get locked down. Intel could lock it down, but people are so smart, especially open source people and people who work on something so close to the kernel as the init system. People are going to crack this, but I don't know, like the one thing that is interesting is like it does take away a lot of the what CPUs do I buy, because I don't know like what I do for my day job. Sometimes we would just get thousands of CPUs. Do you know how many different SKUs there were and how many different Xeon CPUs there were? Like, just if you wanted 6 cores on your CPU, there were probably 8 different 6-core Xeon CPUs to choose from. So when you'd go to Dell to spec your system out or whatever, then you'd end up having to be an expert on CPUs to make sure you're getting the most bang for your buck. So I could see this being like, here's the 6-core Xeon. Now you get it and you install the things you need on it, and then you pay us more for it. But it's the pay us more for it part that I think people are going to get really pissed off about. And if they do it as a subscription, people are going to get really pissed.
Yeah.
Rightfully so. Like this would basically be like if you go to McDonald's and you order just a hamburger and they're like, all right, so we'll make a hamburger, fries, and a drink for you. And you get to sit there and eat your hamburger while looking at your fries and your drink. But if you want the privilege of eating your fries and drinking your drink, which you own, we just put them in a cage.
Right. Well,
if you want the key to that cage,
it'll cost you 25 cents for every 15 minutes you're sitting here inside the McDonald's.
Yeah. And if you decide not to purchase their upgrade and eat those fries and drinks, they don't go back to the store. They go to the fucking trash. Like, these are processors that have this capability, and if it's not being used, it's literally just going to end up as e-waste.
Right. And, you know, I guess I could see it being a cool thing for a consumer, because then the consumers just buy the cheapest one and they're like, actually, I need more power. And that's cool. But I don't see like Intel selling the lowest variant of it or whatever at a loss. So I think it's just going to raise the price, because you're going to get this CPU that has everything. Or maybe there'll be a couple different grades or different sockets, or, you know, they max out at this or they start at this, but it's going to be this, like you were saying, it's going to be this thing where when you are done with the CPU, there's going to be components on it that were just wasted for the entire life of the CPU, unless you end up maxing it out. And so it's just a waste. It seems like a waste, and it seems like a way for them to rip you off.
Yep.
And then what about?
I'm really not a fan of this.
What about the aftermarket? What happens in the aftermarket, right? Because there's a huge aftermarket for enterprise CPUs. There's companies that are on like a 1-year cycle in their data center, and they recoup that money mostly by selling the CPUs out of their old machines to like resellers, people like me, people maybe bigger organizations than me, or people who want to upgrade their current servers. They only have 8-core, and the company's selling off all their 18-core, and so you go buy all a year or two later, those are cheaper, and so you get a bunch more bang for your buck out of your old server that you don't have to replace. Now, what does this do? Like, what happens once you sell it to somebody else? Does it drop all the way back down to like the lowest thing, unless they purchase it again?
Is it tied to your system?
Are they going to use it to basically double dip on the same part?
My guess would be yes. Like, if it's got to be implemented in System D, it's got to be tied to your system. Like, your system has to have some sort of like cryptographic key on it.
Right.
And if you sell the processor but not that key,
they won't.
That processor is just going to...
I bet the key's tied to you or your organization too, right?
Yeah.
It's probably not tied to the CPU itself. It seems like a way they would double dip, and it also like just seems like it would either destroy the aftermarket, or the aftermarket would then be fraught with fraud, or even just people who aren't trying to rip you off. They're like, oh, this is, the 24-core version with this and the virtualization. Then as soon as they take it out of their server, now it's 6 cores, no virtualization. all the cache is gone. You know what I mean? And And maybe they don't even know, right? Because they bought the server from Dell and they were used to doing it a certain way, and they're not the system administrator, so they don't know about the systemd thing. And it was already, they got the system from Dell, maybe with the operating system already installed, or like the system administrators got, documentation with the server and they knew what to do. And so like it's just gonna, I think they're either doing it to double dip, or they maybe don't like the aftermarket.
Yeah, I think this is bad for so many reasons. This is just a really shitty tactic.
And what happens now if your server can't phone home for whatever reason, but you still need it to crunch data? What happens then? Right? What if it's just what if it's a render farm, and so it's not always, it loses internet connection. Okay, that's great. Except what if now, oh man, these are 4-core. What happened? Oh, my internet's down. Like, think about this. You can't play certain video games because your internet's down. Think about you need to get work done.
Not even because of the video game, but because of like your hardware just doesn't work when the internet's down.
Right. Think about like I'm just thinking of like a render farm, right? The render farm it's not a web server. They might not even leave it connected to the internet because it's not for that, right? That's rendering some big project. So maybe the internet's a distraction or whatever to the computers. They go offline to render. But then if you're offline for a week while you're rendering, you're like, wait, why is everything going slow? And then you have to reconnect the thing to the internet, and it needs to tell it again that it actually has these capabilities, even though it has the capability. Like, this is just fraught with problems. And I can't believe Intel's doing this because they have such a good reputation in the data center. It's the one place AMD is probably going to have a very hard time overtaking Intel, just because of their reputation with the Xeon processors for almost 20 years now, just dominating the data center. And they're just, if they go through with this, they're going to shoot themselves in the foot. And why would you stay with Intel in this case?
Yeah.
What if they get mad at you? Like, really, what if they get mad at you? Yeah. I mean, it's a company.
Or what if it is an online service or whatever, and they just discontinue like your model?
Right. Even though, it's the CPU's 4 years old. Yeah, it's not the hottest thing on the planet, but boy, it's still doing a good job of whatever it was doing over here when all the capabilities were enabled, right? But now, we're back to 6-core. Oh man, now we got to throw this thing away.
Yeah, like they're literally just trying to make more e-waste.
It's like planned obsolescence. It's like what they do with, software. They'll do this. They'll sell you the whole software package, right? And then if you buy a different tier, you get more capabilities from the software. You're not downloading the capabilities, right? It's just enabling them because it's stupid for them to send out all these different images of the software where they can just send out one and you unlock the capabilities. But I can't see this being a good model for silicon.
Yeah.
Seems like
once the chip is made, it's made, you can't. I mean, I guess you could add more onto it if you had like a chiplet design, but certainly not like the end consumer would be doing that.
Right. And, some people in their arguments for this are like, well, they already are doing this when they bin the processors. You'll get the same processor as the 8-core, but you're getting the 6-core. And it's like, well, that's not really the same. They're binning it because the 6-core can't run all 8 cores at the speed it's supposed to without overheating. That's why they sell it to you as a 6-core, because it's it's reliable that way.
They're doing that to reduce e-waste, not to make more.
So I'm just imagining these, if this goes through, you're buying this like 48-core processor and you got 12 of them when you start. And then you're like getting pop-ups. It's like, hey, this rendering could be going much faster if I'm just seeing.
Intel pop-up ads.
I mean, I don't think that you can't get it. The data center is not really a good place to put a pop-up because it's like, what's it going to pop up in the terminal you're not looking at? But
it's going to alter your message of the day.
Right.
Just make it an Intel ad.
It's going to spam you. That's what it'll do. Just send you an email.
Yeah, it'll be like,
you want more cores?
Yeah, it'll be like, we see that one of your servers is at 90%. And it's like, get out of here. Why are you seeing this about my server?
Yeah, exactly.
It's early days, and this could it could be a thing where there's only like 2 or 3 SKUs where this happens, and it's only like at the super high end for the data center. And if that's the case, it's not really going to impact people too much. But the problem is, if they do it like that for one generation, what's to stop them from expanding the program if people let it go? And if it somehow they manage not to hack it. If the first day somebody hacks this will be the last day of this program, by the way.
Yeah.
They'll be like, oh, you could buy this processor for $225, and wow, I just bought a 53 core or 52 core processor for $225. Yeah, I just saw this and I couldn't believe it. It just reminded me of that thing that they were trying to do to consumers, where it was basically they were selling you an i3 that was dual core hyperthread, disabling the hyperthread, then trying to get you to give them $50 when the price delta from that Pentium processor to the i3 was $30. So they were actually just stealing $20 from you. But I bet one of those $50 upgrade cards is probably a collector's item, probably worth a good deal of money if you sell it on eBay now. Like if you never scratched it off or whatever, I bet that's a collector's item. And if this goes through and it's a flop, it might not be the worst idea if somebody's a collector of obscure PC hardware to get their hands on one of these CPUs. So
do you think like a couple of Intel execs got together and they're like, hey, you know that thing we did a few years ago that everybody really hate? Let's do that again.
Yeah, but instead of doing it to people at Best Buy, let's do it to DigitalOcean.
Yeah.
Let's do it to Amazon Web Services. Let's do it to big companies that can really make our lives difficult if we screw them over.
Exactly.
Seriously. Like AMD has been making strides in the server market. I'm really surprised that they would be trying this right now.
It might be like anything else where they started trying to this might have started 4 or 5 years ago that they were thinking about doing this.
Maybe.
Because these things move, they move rather slowly, even though it seems like the pace of new stuff coming out is fast. You're still 5 years development, 6 years development, whatever it is for whatever you're buying now to put in the data center. But yeah, I don't understand this. I think I do understand it. They want money, and it's gonna be it's gonna be a subscription service, and it would just be awful. Now, I guess the only way that this would be okay is if they give you the thing for free.
The CPU?
Yeah. And it's just a subscription CPU.
Maybe, I guess.
But then if you could jailbreak it, then why would just jailbreak?
I mean, I would imagine this would be kind of like how phones are right now, right? Like you can go and buy like a really cheap, like a subsidized phone, basically, that's locked to a carrier. And the way the carrier makes, or the way the phone makes money when it's sold to you isn't at the point of sale of the phone. The carrier is making money by you paying for the service, and they're using that money to subsidize your phone. So like it could be something similar to that.
Where Dell actually gives you the CPUs for free because they're the one charging you the subscription service. This is all messed up. I don't like any of it, and I don't want to talk about it anymore. It makes me angry. But good for more good news for AMD. If this is really going on, as long as AMD doesn't say, "Hey, that's a really good idea. Let's do it too," which I would there'd be no market incentive for them to do it because they don't dominate the data center like Intel does. Yeah, that's bad, and that's my segment. It went a little longer than I thought it would, but that was just because we complained about it.
Yeah.
Yep. All right. Shall we close out the show?
You are the readout intern.
All right. Well, thank you for joining us this week. We do this show every week, and we try to get them out early Wednesday afternoon. And if you're listening to this on Wednesday afternoon, come by our Twitch channel, twitch.tv/EchoplexMedia, and check out the Intellectual Dollar Tree. Dave and I host that show every Wednesday night at 7 p.m. Pacific. Check out all of our other shows. You can find them at echoplexmedia.com. remember to like and subscribe and turn the bell on and leave a distasteful comment. Try to get us banned.
Again.
Yeah. But yeah, we'll see you guys next week.